In this video we're going to look at various different ways of controlling loops in your program. So we've seen before that rather than typing the same thing in lots and lots of times, we can set up a loop structure. So we're just going to kind of look at various different loop structures one after the other. Now the most simple sort of loop structure is the for next loop, and we can see one here. So for I equals 1 to 10, then we do some stuff inside the loop, and then at the end of the loop we have this next I. So first time round it's going to put the value 1 into the variable I. So as you go through the loop, I contains 1. Then when it gets to the next I, it adds 1 to that, and then it just checks, have we gone above our limit of 10? Well, no, we haven't, because now it'll be 2, so it's going to zip back to the top of the loop and go through again, and it kind of repeats that. Every time it gets to the bottom it adds another 1, comes through the loop, keeps doing that until it gets above 10. So once we pop out of the bottom of the loop, that value in the variable I would be 11. So let's run through and see what happens here. What we think is going to happen is the first time through it's going to print out I equals 1, it's going to go around the loop, then it's going to print I equals 2, it's going to do that 10 times, so print it up to I equals 10, and then it'll pop out the bottom of the loop, and then at the very end it will just say, after the loop, I equals 11. So let's press run and see what happens. And we can see it's done exactly that. 10 times round it's printed I equals, and then the variable number, the variable value, and then at the end, as we come out, I has increased above 10, so that's why I exited the loop. So what we can do next is we can add this little thing here that says step 2. So rather than just adding 1 every time, this time it's going to add 2. So it's going to start off at 1, go through the first time, it's going to add 2 to that, so it's going to become 3. It's going to add 2 to that, it's going to become 5, and so on and so on and so on. Let's have a look and see what happens when we run this one. So as you can see, it's 1, 3, 5, 7, 9. Obviously the next time it got to the end of the loop, it went from 9 to 11. That was bigger than 10, so we didn't see I equals 10 on the screen, and then it popped out of the bottom of the loop. So the last refinement that I'm just going to show you for this one in our for next loop is we could make that step a negative step. So for example here I've said I want to go from 10 to 1 in steps of -1. So the first time through I will be equal to 10, then it decreases it, decrements it down to 9, then 8, then 7, and so on. And once it gets lower than that end point, that's when it pops out of the loop. So within the loop I will be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. When it gets to 0, it'll pop out of the loop, and after the loop I will contain the value 0. So let's just run that and see what happens. So there we see that's exactly what's happened, and outside the end of the loop it's now got the value 0. Obviously we can make that value -2 if we want to, or any particular value that we want, and when we run it again, this time it's gone 10, 8, 6, 4, 2. Obviously the next time take away 2 from that, it becomes 0. That's lower than 1, which was the end point for our loop. So it popped out of the loop at that point. Now our next loop is the do while loop, which on the face of it looks like a lot harder work than the last loop, because we actually have to code all the incrementing of the counter. We have to set up the initial value of the counter and so on. So it looks like on the face of it, it requires a bit more coding. Now the advantage, as we'll see later, is that you've got a bit more control over how you work your loop, and you can check for multiple conditions to end that loop. So let's just have a look at a simple example to start off with. In this version, first of all, we're setting a value of I equals 1, and we're doing the loop while I is less than or equal to 10. So it checks that value, and it's going to go around the loop. So it's printing the value of I, which first time round obviously I was less than 10, so I is 1, so it's going to print out the value of 1. It's then going to add 1 to I, and then the loop jumps back up to the do while, and it carries on through that loop. Now it's really important that you update the value of I in here. If we didn't do that, this loop would go on and on and on forever, and your program would get completely stuck. But as it stands, let's run this program. As it stands, it basically does exactly what our simple for next loop did, the first one that we looked at. So let's just make this one little change up here. If we start off with the value of I equals 11, as soon as we start our loop, it checks the value of I, and I, obviously being 11, is not less than or equal to 10, it's too big. So in theory what's going to happen is it's going to jump around everything in that loop, it's just going to pop straight out the bottom. So probably what it will say is after the loop is I equals 11, but it won't do anything that was inside the loop. So we see that while, the first thing it does is check the value before it goes into the loop. So let's run that and see what happens. There we go, that's a relief. As predicted, after the loop I equals 11. So it never actually even got into the loop because of that initial value of I. So what I've done now is just to add an extra dimension to our loop. So I've set up I equals 1 at the beginning, I've set up j equals 10 at the beginning, and we're now doing 2 checks. So we're going to come through the loop whenever the value of I is less than or equal to 10 and the value of j is greater than or equal to 5. And so it's got to pass both of those tests before it will go into the loop and do that bit of code. Obviously we have to increment I and mess around with j. So in this case I is looping up from 1 to 10 and j is looping down from 10 to 5. But it'll dive out of the loop as soon as one of these conditions isn't met. So let's run this, and we can see that first time through I was 1, j was 10, that was good. 2 and 9, 3 and 8, 4 and 7. The last time through it got to I was 6 and j was 5, and then of course I was incremented to 7, which was still okay, it would have carried on around the loop, but j was now decremented to 4, and that's too small for us to carry on through our loop. As we can see here, j needs to be bigger than or equal to 5. So the last slight variation on the theme that I'm going to talk about for do while is, instead of using the AND keyword in here, so well, I is less than or equal to 10 and j is greater than or equal to 5, I'm going to use OR. So basically either or of those conditions have to be met for it to come into the loop. So last time with the AND, both had to be met, but this one it's just either one. So if I is less than or equal to 10 or j is greater than or equal to 5, it will carry on going through the loop. So this time it's not going to stop when j gets to less than 4, because I is still less than 10. Then it's going to carry on through the loop because one of these conditions is met. So let's run that and see what happens. So there we go, it's gone all the way through the loop, and because I up until this point was less than or equal to 10 and j sort of bombed out at this point, but because this condition was still met, it still carried on going through the loop right till the end until both of those broke their conditions. And lastly, let's look at the do until loop. So in this case, again, we have to put in all the code where we set up the initial conditions and where we do the incrementing or whatever it is, our little checks in the loop, and then so there's a bit of extra code around the edges over the for next loop. So essentially what's going to happen here, we set up the value I is 1, and we're going to do this loop until this condition is met. Now obviously we start off with I is equal to 1, I is less than or equal to 10 straight away. So what will happen is that will come straight here, it will do that check, and it will say, oh well, I've done the loop until that's the case. Now that that is the case, I'm going to jump straight out. So when I run this, it won't do any of the code inside the loop, it's just going to bomb straight out because that condition is met straight away. So let's run and see that. There we go, after the loop I equals 1, so it didn't do anything inside the loop. So if I started off with I equals, let's say 20, and inside the loop I'm taking 1 away, initially I is not less than or equal to 10. It will start off at 20, then it becomes 19, but as soon as it hits 10, then it's going to bomb out of the loop. So let's run this and see what happens. All the way down here, when I became 10, it was less than or equal to 10, so it didn't do the code that was inside the loop at that point, and it bombed out of the loop. So as soon as it hit 10, it came out of the loop with a value 10 in it, because I had that less than or equal to. Okay, so if I'd have changed that to less than 10, let's see this one again. So this time round, when it hit 10, it did carry on through the loop because I wasn't less than 10, and then it didn't bomb out until I became 9. Right, this is where it all starts to get a little bit mind-blowing. If you've enjoyed what we've done so far, then you'll love this. So this time round, I've got two variables again, I and j. I start off with I is 20 and start off with j is equal to 1. Now it's going to do what's in this loop until both of these conditions are met. So until I is less than 10 and j is greater than 5. Now as we can see here that obviously I takes a while to get down to 10, so it's going to take 10 loops for it to get down to 10, but j will fairly quickly reach 5, so it's only going to take half as many times around the loop for j to be greater than 5. Now because both of those conditions need to be met for it to jump out of the loop, it's not going to jump out until I has reached 10. So even though j is greater than 5, it will still carry on going around the loop. Let's see that in action. I went all the way down. Although j was bigger for this part of the loop, because we'll be using the do until structure and the and connective in there, both of those conditions had to be met for it to jump out of the loop. So you've got to be really, really careful when you're doing do until, otherwise you might create an infinite loop and that will just go round and round and round forever and never match both of the conditions for it to jump out of the loop, and your program will just basically blow up. So now I've changed that word here to or. What do you think is going to happen? So we're going to do the contents of the loop until I is less than 10 or j is greater than 5. Okay, what do you think? Let's run it and see if you're right. There we go. When either one of those conditions was met, it jumped out of the loop. So as soon as j was greater than 5, it jumped out of the loop, even though I still had quite a way to go before it became less than 10.